And then
Thank
I would
you,
like to
and
say welcome to Andreas Okholm, who is the founder and CEO of KiteX in Denmark. Andreas, you are on now. The screen is yours.
thanks. And can you perfectly see the presentation now?
I think so, yes.
Yeah, okay, that's great. Yeah, so as introduced, I'm the founder and I started KiteX. We actually started about 4 or 5 years ago building flying wind turbines, but we now changed into making these portable wind turbines designed for off-grid and outdoor use. And really the inspiration to work on these alternative design comes from flying kites. I've been a kite surfer myself for many years. And what's really fascinating when you work with kites is the amount of energy that you can harness with such a light structure. So I mean, that has brought many engineers to think about, I mean, how could you sort of use the technology of kites to create wind power, and that's what we've been working on. And then just from a market perspective, what we I think figured out about a year ago is that, I mean, portable energy is becoming a thing, and this market, as you see here, for these portable generators with portable solar it's a rapidly growing market. And that's what we want to design, a wind turbine that's really intended to be sort of compatible with these portable generators and you could say occupy the same place in that space. So one of the trouble with those existing solutions is, I mean, you have the generator obviously, but a lot of people want something that's less noisy and they don't really like to transport fuel. Existing portable wind turbines, they typically only produce about 5 watts at most. They don't really feature that big rotor areas, so it's hard to generate any meaningful power. And then we also feel that there's a need beyond just the solar panels in case you are camping or are places where it's a lot darker than sort of near the equator. So yeah, so we designed this portable wind turbine, and here's a view of it. One of the unique aspects is that it features, you could say, strings or guy wires to hold all the forces. And you can set it up with the ground anchors, so you don't need a permanent foundation. And here, so the idea is that you take your camper and then you set it up and you can consume the electricity. And so the reason why this is technically possible, or how you could say to make a much lighter portable turbine, is that we transport all the forces in tension instead of as torque or moments through the structure. And then on top of that, we also have a very active control system that's needed to control both the loads, but also you could say the speed and torque of the system. So in a way, it's quite an advanced turbine that we are trying to build, being so light and also using active control. And our turbine, the main one we're making, is a 600 watt rated turbine. Then from this pictures, you have the generator up there. You also have a small electronics control box. Then the power runs through the tower down to the ground and over to this portable power station, which is basically a small box with a battery and inverter and charge controller inside. And then you plug in your appliance into this portable power station. So that's the typical recommended setup we have. Just to sketch it out even further, so that we actually connect like using the same cables as you would with a portable solar panel or any solar panel. So we use these MC4 connectors, and we from like the from the point of view of the MPPT charge controller, we actually just a PV solar panel, and we sort of, I mean, just turn on the output on from the turbine, and then provide almost like a DC kind of output to the charge controller, and the charge controller is able to figure out what to do. You can also, I mean, instead of using with a box, you can also use a more conventional setup with a external MPPT charge controller and an external battery system and separate inverter. That's also possible. And yeah, just yet another picture of the turbine, just also to explain a little bit more about like what we have. So you can see here that the blades are supported by blade lines, and we both have upwind and downwind lines, and that's to add rigidity to the structure, and also you could say in case that the wind suddenly changes direction, then we don't want the blades to collapse. So that's why we have the downwind blade lines. And then the torque is transferred through these blade lines down to the triangle, which the generator is also sort of attached to. And from there, so one thing we do transfer is actually the torque of the rotor needs to go through the top boom and into the tower. And then you also have a small moment from the actual overhung rotor that's then also transferred to the tower through this main boom tension belt. And then actually the whole tower can rotate. We've just figured that was the easiest to build. We also tried with just the top part rotating. And then we use ground anchors, and it could be a different kinds, but as drawn here, it's these spiral ones that you drill into the ground with sort of screw them in. And how is it possible, you might sort of ask, to just connect it into a PV inverter or PV charge controller? And the reason is because we have this turbine control box where we actually have built-in batteries. So we, inside our turbine, have a very small battery that's able to charge or discharge very quickly. And then we use an electronic speed controller that you can see on the left to actively control the torque and current coming out of the generator into the battery. Then we are also able to, on the output side, turn it on and off, and then dump power out to the charge controller. And then we also, just for completeness, have a IMU, which is a accelerometer and gyro to measure vibrations and so forth, that we can also use for diagnostics and turning it on and off. So some of the key features of the turbine is that it's very lightweight, it's portable, it's fast to set up, and compared to solar, you're able to charge at night. We've specifically designed it to be low noise, of course not as low noise as probably the previous tulip turbines or a solar panel, but it's something that we really try to work on. That is just some noise in the background, sorry, or I mean somewhere else. And then we optimize it for low wind. We have an extremely large rotor area. The diameter is 4 meters, but we just try and capture 600 watts at the maximum. And lastly, it's designed to be as plug and play and possible. We use recycled materials, and you can set up with one person. And this is our power curve that we have for the turbine. What we have confirmed, or like from testing, that we're able to produce over 500 watts. We're still working, you could say, above rated power or rated wind speed, about between like 10 and 15 on the control strategy and optimizing that so we can get as close as possible to the 600 watts. We might not in reality be able to hit the 600 watt in the whole spectrum, but we probably can get pretty close. And then we use the electronic control to shut it down when it gets too windy. And since we're using a belt drive, we cannot really hit like, I mean, extremely low startup wind speeds, but I think still pretty reasonable. Now I just want to show a video of one of the early prototypes spinning. This is even it's probably hard to see, but a interesting one, because it has like each blade had a small tail on it for this test that we used to try and stabilize the blades in pitch. Here you can see all the components one of these turbines consist of, and yeah, it's able to assemble into a box that you can ship with a regular postman, basically. And this is the setup that, if you are really fast at the moment, can be done in just 15 minutes from getting out of the car to having it running. Here, some of the things that really takes a lot of time is actually setting up the earth anchors in a proper way, and there's still some, you could say, line management that you need to do. But we're trying to move towards a point where you don't need any specific tools. You can just sort of screw together these parts and we'll assemble. Yeah. Just to talk a little bit about some of the challenges, I think the main challenge we have is actually still the gearbox design. So partly because the rotor is so large, and we want it to be so lightweight, we need a very large gear ratio for this to make sense. So in this case, you can see this is an original design we had, where you had I think 22:1 gear ratio in one stage, which definitely has some advantages. It's very efficient, but it's also hard to get the alignment of these parts to work. So we tried another design. We also tried like a 2-stage design here, also in plastic, and I think that was like an improvement. And last but not least, we also, you could say, see here we have like a 2-stage design in aluminium, where the forces are transferred through that aluminium block, and hopefully that will give us the performance we needed. But I think that has been really one of the most challenging aspects of building the turbine, is the lightweight gearbox. So if you have any input on that, or like think that, oh, you could just buy this part and then you would be happy, I would be happy to learn about it. In terms of the market that we're going for, then yeah, initially, as I mentioned, we want to do this off-grid camping, off-grid power that is primarily compatible with these portable power stations. And then once we believe we can get a little bit more mature product that has a longer, you could say, time between service, then we want to go into a little bit more professional use cases, emergency response, refugee camps, and perhaps also military operations. And lastly, but not least, maybe we hope that we in the future can actually power homes living off-grid. So that would be really exciting. And we also, yeah, like the technology need to follow, so right now we're focusing on something where it can maybe run for 8 weeks at the time between service, but then we want to really improve the reliability in the coming years, and then we want to scale it up to probably about 5,000 watts later. And just briefly mentioning the team, I mean, we have me. I have an aerospace engineering background, but I also have a lot of entrepreneurial experience. We have Christoph, who's a physicist, and then we also have Christopher, who's a mechanical engineer. So I think we cover most of the bases. And all of us, we have a background also, yeah, from working with these flying wind turbines. I just want to give you a picture of what that looks like. This is one of our prototypes that we built last year, but we actually stopped working on, flying in a circle. This is actually like a 3-meter wing. Here's another more close-up picture of it. That is flying at the end of a 80-meter tether. So we stopped this line of development, but that's where we come from. In terms of people on our advisory board, we have 3 very competent, little bit older men, if you will, that has focused on R&D and also the wind industry. And also in our network, we are happy to consult both with D2 Wind Energy, but also I think some of the best or most famous, if you will, within the wind industry. And they are happy to consult on these topics. Then just to round up, I have a small video just showing the turbine in a few different settings. Also a car. So here the turbine is running. You can see you can power your fridge if that's what you want. And let me go somewhere else. You can make pancakes, of course. That's also pretty fun. And you can go to a summer house, get some light, or you could charge your electric bike. We also tried that. So here it's actually running at quite some wind, and and here it's running a stall regulated. So I think that must be it. About 8 seconds to go. Yeah. So thanks for listening, and I'm happy to answer a lot of questions, hopefully.
Thank you very much, Andreas. First, we have a question from Garrett.
Yeah.
Hi, Andreas. Garrett Smith from Windfisher. I was just wondering why you left airborne wind energy to focus on small wind, what the motivation was behind that.
Yeah, so I think there's 2 reasons. For one is that it would take too long still, at least with the technology we used to get to a commercial state. I would still easily imagine it would take another 6 years of development for us to get something that would be viable, and I'm not really sure it would be worth the effort for us. And also Makani closed shop, I think about a year ago or something like that, and they also released like a pretty lengthy report on some of the challenges they saw in the industry, or for flying wind turbines, and I think at least for the ones with onboard generation, it's hard to see if it really makes a lot of sense. I think building a lightweight structure that stands on the ground is probably makes more sense. Yeah.
All right, thanks.
Yeah.
Other questions?
Fritz has a question.
Yes.
Okay. In the early days of small wind, we used also belts. And then there was a discussion about what is your safety brake when the belt is broken?
Yeah. Yes, that's a good question, right? So, I mean, one of the things we have been working on is actually trying to make a release mechanism for the lines that's such that if you exceed a certain rotational speed, you have a passive mechanical system to pitch the blade out. So that's one we've been testing. But we are working on various mesh methods in that regard. Yeah. But I would be happy to learn, if anybody really solved using belts for wind turbines, or also learning like if they just have some inherent disadvantages that I need to be aware of.
Yes. Andreas, how is your experience in crowdfunding and financing?
Yeah, thanks for asking. Yeah, so I think also one of the interesting aspects of our project is that we actually crowdfunded the turbine on Kickstarter. So we sort of presented the turbine as you saw it here and asked people if they would want to buy it for about 1,500 euros, and then with delivery in December this year. We have about 80 turbines we sold in this fashion. So right now we are trying to get the final details of the design done, and then we need to deliver turbines later this year. So that's super exciting.
Did you have any tests performed according to some standards?
No. So what we at the moment we are just testing the turbine ourselves, and probably will definitely need to get more rigorous with the, you could say, the external testing and certifications. That's really a thing that honestly worries me a lot, particularly because I'm not really sure that, I mean, the standards are really applicable to our turbines. I think we'll probably be running into a lot of walls, but we'll see how it goes and how far we can get.
Yeah. Well, as you know, we have a test field and center here in Denmark, so it could be one of your new network. Yeah,
for sure.
Sure, because if there's a chance to have it commercialized in a way that people feel safe about, that must be a issue as well. There is a question from Mike.
Yeah, so Andreas, I was wondering on the blade tabs that are shown in some of the pictures, is that an attempt to pitch the blades, or is that to address a flutter issue?
It's mainly just to address the flutter issue. So as the design is, it's a fixed pitch system, but because the blades are so long and slender, they will flutter at high enough wind speeds at about rated power if you don't have these tabs.
Yeah, so we ran into, in 1978, ran into the same problem with our first turbine. It had aluminum single surface airfoils. If you can get the mass axis out in front of the elastic axis, it'll be stable. So, you know, if you put the weight out front instead of behind, you'll get the stability you're looking for.
Okay. I'll just write the note down.
Yeah, but also flutter can be your friend if you get a runaway. Because it's better to make a little noise than to spread debris.
Yeah. I mean, I've definitely seen that it will limit the RPM a lot in runaway situations, and I can definitely say, given that we have this belt design, that we have had a lot of runaways. Fortunately, because of all these lines, that, I mean, everything they never really fly that far away from the turbine in case of a problem.
Thanks.
Yeah, and also I think maybe that's also why, I mean, from a safety point of view, I think, I mean, that of course we don't want these turbines to fall in people's heads, and especially it's dangerous when you are getting close to the turbine. But the blades are actually made of foam, primarily, of course, with a carbon fiber spar, and then it's a plastic film on the outside. So I mean, the blades themselves, they weigh 200 grams, and and basically are more to think of them like a sword that you would use for as like a play toy. So they don't seem so dangerous when you actually get close to it, but maybe from the pictures it looks dangerous.
Okay, thank you very much, Andreas, and we will find time to catch up if there are further questions. But now it's time for the next speaker, and that will be evaluation on small wind turbines for rural electrification, case studies from extreme climate conditions in Venezuela. And Alejandro Gonzalez, welcome to you, and thank you very much, Andreas.
No worries, thanks.
Is not on board yet?
Question from Niels Christian.
Well, in the meantime, we'll take a question from Niels Christian Olsen.
Yeah, it was just a proposal that maybe if you have a wire going through the axis, the rotational axis, and could pitch the blades, so prior it start up, you pitch it into operational mode, and if it starts to run wild, you can just pull the wire so it pitches out and then it stops. Because everything is rotating together, so maybe you could have a wire going through the rotational axis to pull the blades into position. It's like the tail system on the Fortis turbines. You can pull a wire to collapse the tail so it yaws out of the wind.
Yeah.
Like, yeah.
I mean, we're thanks. Yeah,
yeah.
Thanks for putting it out there.
Yeah.
Yes. Are there any, well, we can continue because our next speaker has not come in yet. So are there further comments or questions for Andreas?
Yeah, hi, it's Brent Somerville from the US. I don't think I was able to purchase one on Kickstarter. Which countries are you promising initial shipping to?
Yeah, so we are promising the US and Europe, basically. So that's the idea. And yeah.
Great. Thank you.
Thank you.
Andreas, I was going to just ask you whether you own your own 3D printing machines or you vendor that out, because it looks like you make a lot of use of 3D printing for your prototyping.
Yeah, so part of our strategy is actually to also for a lot of the commercial products to 3D print a lot of the parts. We have 15 3D printers at the moment, and we intend to get about 50 for the first production run. And these are low-cost machines, but they're definitely good enough. Yeah, and I can also add that, I mean, this design would probably be, I mean, almost impossible to prototype and build without a 3D printer. So I think that's one of the key things that, I mean, makes this possible, at least with the amount of funding that we have, is using 3D printing. And also, of course, the materials we are using, I mean, glass fiber, carbon fiber, and these Dyneema lines are also special, right? I mean, the last time people tried to use these guy wires on blades, it was, I guess, in the 70s, and then you use steel wires, and these are a lot thinner and a lot lighter and a lot easier to work with than steel cables. Yeah.
Well, if no further questions right now, I think, well, the next speaker has not shown up yet, so I think we'll just take a break now, and you can have some refreshment or coffee or whatever you will, and then we'll meet a quarter past 11. That's in 20 minutes from now, and then I wish you a good break.